Hello, beautiful people, and welcome. This is going to be a review of something we've been covering, solving exponential equations. But before we continue, I want to point out the new website. So if you go to teachingsilvanusmath.com, you're going to come across a page like this. Let me get my cursor here. And you have a chance to go directly to YouTube and watch videos there. If you would like to meet Silvanus, just click on Meeting Silvanus and you can meet exactly who Silvanus is. There we are. There she is. Isn't she cute? And then if you go back to the main screen, you can click on either Math Foundations, Integrated Math 1, or Integrated Math 2. Those are the videos that I have up right now. So if you go to if you go to Integrated Math 3, you can see all of the videos that I have posted right now. And then I will continue posting videos daily. So let's go ahead and get started. So let me go back to my home screen. And let's get back to our review. Okay, this is the review for solving exponential equations. So we're going to be talking about all of the tricks that we can, all of the properties that we need. Let me get rid of this guy. There we are. All right, so solving exponential equations. Let's start with number 1. Solve each equation. So the first thing we notice is that our bases are the same. I have a base of 3 and I have a base of 3. When the bases are the same, great things happen. We can use our exponential properties. And so the exponential property that we're going to be using will help us combine things with the same base. So we're going to be using the product of powers. Okay, so what that means is if you have something with the same base, the exponents here, you can add. So I'm going to rewrite this as 3 to the power of 3 minus 3k plus 1 minus 2k. And that's equal to 81. We haven't touched the right-hand side yet. All right, I'm going to zoom in just a little bit, see if we can get a little bit more clarity on that. All right, so since we're going to add that, I'm going to simplify. So I have 3 to the power of 3 plus 1 is 4. I have minus 3k and minus 2k, that is minus 5k. That's equal to 81. Now, here's the thing. We're going to change the base. So what I mean by that is, you notice that we have a base of 3 here raised to an exponent, and we have an 81, okay? So we can't really do anything with that unless the bases match. So take your trusty calculator. If you already know what this is, fantastic. But what we're trying to do is we're trying to get 3 to the 4 minus 5k power equal to 3 to something power. So we want to rewrite 81 in terms of a base of 3. So 81 is, let's see, we know it's going to be 3 to the 4th power. Now that you're here, you're going to set the exponents equal to each other. So what's really great with the 1-to-1 property is that if your bases are the same, your exponents are equal if you have this setup. So you have a base to an exponent is equal to a base to an exponent. If you have that set up, then your exponents are equal. So I'm going to bring that back up here. So I have 4 minus 5k is equal to 4. I'm going to subtract 4 both sides. So I have negative 5k is equal to 0. At this point, you don't have to do this step, but if you want to, so k is equal to 0. And that is our answer for number 1. Now, I don't believe I mentioned my disclaimer. Disclaimer is, if I make a mistake, I am human. Just let me know where the mistake happened, so that way we both can learn from my mistake. Also, if you hear a loud bell or an intercom, I apologize, But in this video, you will not, since I am recording at home. So there is a different disclaimer since I am at home. If you hear any noise in the background, that is Miss Sylvanas playing, running around like she's never seen sunlight before because it's been raining for the last couple of days. So let's go ahead and do number 2. Number 2 says, I have 125 to the negative 2v power, and that's equal to 1 over 25. The first thing I'm going to do is I'm going to get rid of this fraction by using a negative exponent. So I'm going to say 125 to the negative 2v power is equal to, I know that I have 1 to the 25th power, which is the same thing as 5 squared. And I'm going to just go from here. I know that 1 over 5 squared is the same thing as 1/5 squared. And again, since I don't want it to be a fraction, I'm going to go ahead and take the reciprocal of this by making my exponent a negative. So I'm going to say I have 5 to the negative 2 power. So I'm going to go back here, and I'm going to say I have 125 to the negative 2v power is equal to 5 to the negative 2 power. Now we can't do the one-to-one property like we did to here just yet. We first need to get my bases the same. Right now I have 125 and I have 5 as my bases. So I know that I can rewrite 125 in terms of 5. So I'm going to do that. 5 to the 3rd power. I'm second guessing myself, so I'm going to ask Google. Just kidding, ask my calculator. So that is correct. Now, the way to deal with the existing exponent. So you have 5 to the 3rd power. That is your 125. You still have an exponent of negative 2v. So now we're using another property of exponents. And that says, and it is the, I'm looking at a cheat sheet here because I don't know the exact name of it, but it is the power of a product property. All that means is, just kidding, it's the power of a power. There you go. I can do math. Power of a power. What that means is, since you have an exponent raised to an exponent, you're going to multiply these two together. So we, on this one, on the right-hand side, we still have 5 to the negative 2 power. So then here, I'm going to multiply 3 by negative 2v. So I have 5 to the negative 3. Just kidding. That is a 6v, negative 6v, and that's equal to 5 to the negative 2. So now I can do my one-to-one. Since I have a 5 as a base and a 5 as a base, I have a base raised to an exponent equal a base to raised to an exponent. So that means I have negative 6v equal to negative 2. How are these attached? By multiplication. How do we undo it? By division. So I have v is equal to, these cross out, 1/3. I'm looking to see if there are any other ones that I believe could be tricky. Let's try number 3. I think maybe number 3 can be tricky. Now this one is tricky because there's not much to do. You just kind of have to know this. When it's equal to 1 like this, there's no way for us to change this base. I take that back. Let's change the base. There is a way. So let's rewrite this. You don't have to do it this way. I'll show you the other step. So to rewrite 1 in terms of a base of 3, we're saying 3 to what power is 1? So we're saying 3 to what power is 1? And the only thing that 3 to the power of is 1 is 0. So 3 to the 0 power. So again, bases are the same. Exponents are equal. So 3x is equal to 0. Therefore, x is equal to 0. Now, you did not have to do it this way. If you go back up to the first step here, 3 to the power of 3 times x is equal to 1. The only way that this can be equal to 1 is if 3, this section right here, is equal to 0. And the only way that 3x can be equal to 0 is if if x is 0. So when x is 0, 3 times 0 is 0. 3 to the 0 power is 1. So if you saw that, that's fine. You don't have to do these steps. But if you didn't see that, that's okay. Do it this way, the way that we have been doing. All right, let's move on to number 4. All right, number 4 says 6 to the negative 2m minus 2 times 1 over 36 is equal to 36. So now I'm going to do exactly what I did here with my 1 over 25 because I don't want a fraction. Fractions are our friends. We do love fractions, but we also want to rewrite them in a prettier way. In this case, we're going to use negative exponents. So I have my 6 to the negative 2m minus 2 times, again, same method that we did here, except now instead of 5 squared, we're going to have 6 squared because 6 squared is 36. So I have 6 to the negative 2, and that's equal to 36, but I'm going to jump ahead and say 36 is 6 squared. How do I know that? Because I see a 6 here, and I know that 36 can be rewritten in terms of 6, and I know that 36 can be rewritten in terms of 6. So therefore, my base is 6. Now, we have, back to example number 1, we have the base that's the same, we have the base that's the same. So now we're using the product property, which means if the bases are the same and it's being multiplied, we add the exponents. So I'm going to say 6 to the negative 2m minus 2 plus negative 2. You want to combine without writing the step out? Go for it. So now I'm going to say 6 to the, what do I have? Negative 2m minus 4 equal to 6 squared. Now again, we have a base exponent equals base exponent. Since the bases are the same, the exponents are equal. So negative 2m minus 4 is equal to 2. I'm going to add 4 to both sides. So 4, 5, 6. Negative 2m is left over. I'm going to divide by negative 2, divide by negative 2. M is equal to negative 3. All right, I'm actually going to stop there. I feel that these 4 examples do show you a few methods of how to solve these things. Remember your properties, remember your one-to-one property. If you have any questions, please let me know, and then I'll see you next time. Thank you for watching.